Welcome back to the Network Engineer Diaries. I'm your host, Jimmy Shaka. Today we are going to talk about ACLs, access control lists. Access control lists are sets of permit and deny rules that we apply on a switch port or a router port to control what traffic goes through or what traffic gets denied from going through a switch or a router. ACLs, for that purpose, are used in securing a switch and a router by blocking or allowing a certain type of traffic. ACLs are also used in identifying the traffic that needs quality of service in QoS policy. ACLs are also used to identify a traffic which has an IP address that needs to be translated to a public IP address using NAT policy, network address translation. There are these types of ACLs. There are standard numbered. Those range from 1 through 99. There is also extended and numbered ACLs. Those go from 100 to 199. But also with the modern switches and routers, Cisco has expanded those numbers to include for standard to go from 1300 to 1999 for standard, and from 2000 to 2699 for the extended numbered ACLs. There is also standard named ACLs, and then lastly there is also extended and named ACLs. Today we are going to talk about standard and extended numbered ACLs. As you can see here on the left hand side, we have a topology that consists of 5 computers: computer 1, 2, 3, 4, and 5. We have a switch down here. We have a switch up here, SW2, and then we have router 1 and then router 2. So we are going to configure ACLs on our network to control the traffic, to demonstrate how numbered standard and numbered extended ACLs are used, okay, to demonstrate this. Before we start, I have configured these computers with these IP addresses as per this topology. Computer 1 has this IP address in the /24 subnet. Computer 2 has this IP address with this subnet mask. Computer 3 that, computer 4 that, 10.0.0.4/24, and then computer 5 up here in a different subnet. It has 10.0.1.5/24 submask. And then router 1 has 3 interfaces: interface fast Ethernet 0/0 facing towards these 4 computers, and it's configured with gateway IP address 10.0.0.9/24, and then interface fast Ethernet 0/1 that's facing towards R2. It's configured with IP address 10.0.10.1, and this interface facing towards PC5 is configured with IP address 10.0.1.1/24 submask, and it's on interface fast Ethernet 1/0. Okay, you can verify that those configurations here on router 1. Show run. Here we go. That's the IP address setup on fast Ethernet 0/0, IP setup on fast Ethernet 0/1, IP setup properly also on fast Ethernet 1/0 interface. So that's good. Next, router 2 has been configured with static routes to these 4 computers to the 10.0.0.0 subnet, okay? And it's also been configured with a static route on how to reach this computer in the 10.0.1.0 subnet, okay? A quick refresher on how to set up static routes. You can watch a video up here. And also, I have configured telnet on router 2. Again, there's a separate video that I made about telnet as well. Go ahead and watch this video up here in the pop-up to see how you configure telnet on a router. I have also included a link in the description section below. Okay, I have configured R2 to allow a total of 5 PCs at a time to telnet to R2. Should be good to go. Okay, before we start configuring ACLs, let's verify and check that PCs can ping and telnet to R2. Okay, let's verify that all these 5 PCs can ping and telnet to R2. Starting with PC1, first computer. Okay, it's ping R2, and this is R2's IP address. 10.0.10.2. So the ping is successful. We are getting replies from R2. Let's check if we can telnet from PC1 to R2. Okay, perfect. A quick reminder as well, I have set up the user exec mode to use username Jimmy Shaka, my first and last name as a username, and then the password is Cisco. To access the global config exec mode, I have configured the password Cisco admin. Okay, so let's go back on PC1. Let's try to telnet to router 2, telnet to 10.0.10.2. It's asking for the username. My username is my first name, my last name. Password is Cisco. Now we are on router user exec mode. Enable. It's going to ask for the global config exec mode password, which is Cisco admin. See, we are now inside router 2. We can show the running configurations on router 2 using PC1. Let's do the same with PC2 to just demonstrate that we have connectivity across on all computers. Ping 10.0.10.2. See, we have connectivity to R2 from this laptop, computer 2. We can also show that we have access using telnet. Username is Jimmy Shaka. Password is Cisco. And enable to reach global configuration mode. And the password for that is Cisco admin. Oops. Cisco admin. Okay. Show run. We are on the router now using computer number 2. Let's go on computer 3. You can see that we also have access to R2 using computer 3. We can ping 10.0.10.2 successfully. See, the ping is successful. We can also telnet to R2 easily. Cisco, Cisco, username Jimmy Shaka, password Cisco, enable to reach the global configuration mode, Cisco admin. Okay, can show the running configurations for the router using PC3. PC4 also has connectivity to R2. Let's try to ping 10.0.10.2, which is the router. See, we have connectivity to R2 using PC4. Now let's try to telnet to 10.0.10.2. See, it's asking for the username and the password. Oops, Cisco is the password. Now, username again. Username Jimmy Shaka. Password Cisco. To reach the global config, password is Cisco admin. Okay, show running configurations. We are now inside router 2 using PC4. Now, PC5 also has connectivity to the router, to router 2. Okay, ping 10.0.10.2. See, we can ping R2 using PC5. We can also telnet to 10.0.2.10.2, which is router 2. See, it's asking for the username, password Cisco. We are now inside the router. Password was Cisco admin. To reach the global configuration mode, we can show the running configurations that are on the router. See, perfect. Now, see, we have connectivity to router 2 using all 5 computers. Next, we are going to configure a set of access control list requirements to filter out and deny or permit traffic from these 5 computers towards R2. Okay, first we're going to use a numbered standard access list on router 1 to deny the traffic from all PCs from the 10.0.1.0 subnet. Okay, we're going to deny any computer that's inside this subnet 10.0.1.0, which is this computer. We're going to deny that anything that's in the subnet from reaching router 2. Okay, but on the same token, we're going to leave computer 1, 2, 3, and 4 with their connectivity towards R2. We are going to leave these 4 computers with their access to the router 2. But also, computers should be able to communicate between themselves. That means 1 through 5 should be able to communicate between themselves, but PC5 should not be able to reach R2. That's the only forbidden traffic. Okay, in the end, we're going to check and verify whether the configurations have been done properly. Let's start. So let's go on R1. Let's configure the standard numbered ACL on router 1. We go to the global config mode, access list, deny, access list 1, deny. We're numbering it 1 because standard ACLs use, numbered ACLs use any number between 1 and 99. Extended, they're gonna use 100 up to 199 for the old versions. The newer versions use up to these numbers and that number. So back here, so we're naming it number 1. Next, deny subnet 10.1.0 with the wild mask of 000.255. So this is the inverse of the submask, okay? 255.255.255.0. The inverse is 0.0.0.255. So that's good. Next, we are going to permit. We're going to permit anything in the 10.0.0.0 subnet, okay? So because that's what the tasks are saying, we are going to allow all the computers 1 through 4 which are in this subnet to maintain connectivity through router 1 in order to be able to reach R2. And then that should give us what we needed. Exit out of here, go to the, now we're going to apply the ACL on the interface port, okay? So we are going to fast Ethernet 0/1 IP access group 1 to the number of our ACL out. Okay, let me explain here something real quick. We are saying any traffic that comes through here trying to reach through router 1 but going to R2 coming from PC5, go ahead and block it. Anything, okay? But if that traffic is intended for the 10.0.0.0 subnet, which is technically speaking of these 4 computers down here, go ahead and allow that. That's what we're saying. So PC5 should be able to communicate with these computers, but it should not be able to communicate with that router. Okay, and then the word out means we are applying this rule on the outside interface, which is this part right here. So the traffic is coming in on this side and then going out on that port. So that's why we put out on here. Okay, and now we're done. Let's verify and see whether this is configured properly. Now let's check that computers 1 through 5 still have connectivity to each other. Let's go on PC5. Let's see if we can ping PC1 at 10.0.0.1. See, the ping is going through. Okay, let's see if we can reach computer 2 down here. See, the ping is also going through. How about PC3? Can PC5 reach PC3? It's also going through. How about PC4? See, it's also going through. How about PC1 trying to reach PC4? Can we have connectivity that way too? See, is also working great. Great, we still have connectivity among the computers, okay? Now, let's verify and see that computer 5 cannot ping nor telnet to R2, okay? The new ACL we have applied, the ACL we have applied on R1 should deny PC5 from reaching R2. Let's try and see if that's working. Let's try to ping the router. See, the destination is unreachable. This router right here is denying PC5 from reaching router 2. How about telnet? Telnet to the router R2. It's also denying telnet session towards R2. How about PC1 trying to ping again the router? PC1 is going through router 1, no problem. How about telnet? Let's telnet to the router number 2. It should work. Exactly. See, it's asking for my username and my password. To reach the global config, the password is Cisco admin. See, now I can check the running configuration on the router using PC1. Same thing with PC2. Should be able to ping the router. See, we're pinging the router. As a matter of fact, all these 4 computers down here, they still have the ability to ping router 2 and telnet to the router number 2. See, we can telnet to R2 using our computers that are set up in the 10.0.0.0 subnet. Okay, these are not being blocked, but PC5, computer 5 is being blocked from reaching router 2. So that's the first task is successfully accomplished. Okay, this is done. Next, we're going to configure extended numbered ACLs on router 1 to allow only computer 1 and 2 to telnet to R2, and then we're going to deny every other computer that's in this subnet. So that means 3 and 4 are going to be denied the telnet session towards R2. Okay, but all other connectivity to R2 must be maintained. Okay, that means all computers down here should still be able to ping R2, but only these 2 should be able to telnet to R2. 3 and 4 should not be allowed to telnet to R2. And also, all 5 computers should still have the ability to ping each other. Okay, let's configure that. So you're going to use extended ACL config T access list 100. Now we're going to use 100 because, like we discussed earlier, extended numbered ACLs use any number between 100 and 199. So let's use 100, and we're going to say permit TCP traffic from host 10.0.0.1, that's PC1, and every time it tries to reach host, let me expand this so you can see clearly. Okay, we're saying we're creating the access list 100, ACL 100, and we are permitting TCP traffic from host 10.0.0.1 to reach host the router IP address, which is 10.0.10.2 on the port echo telnet. So telnet port. Okay, we can use echo 23 or the word telnet here. Good. Next, we are going to permit the second computer right here, which is 10.0.0.2. We're going to give it the permission to reach our router, and if that traffic arrives on the telnet port, or port 23, let's use a number, let's use a number 23 instead to demonstrate that it's all the same. Okay, next we are going to, I'm using the upper arrow to bring up my most recent entry. We're going to deny any TCP traffic from, this time it's not any specific host, but instead it's the remaining subnet, it's the remaining computers that are in the subnet 10.0.0.0, okay? Because that's what we have been asked to do, okay? We are going to deny, see this task right here, it says deny all other computers in the 10.0.0 subnet. So we're denying everything else, okay, from reaching host 10.0.10.2 if it arrives on the port 23, which is telnet. Okay, good. Next, we are going to allow access list 100 IP. Let's permit IP any. So by default, at the very bottom of your SC entries, access list entries, the deny and permit entries, there is a default entry that denies everything else. So we have to intentionally permit everything else if you want everything else to be permitted. Okay, what we were saying here is anything else that comes on to the router, go ahead and permit it, and if it's coming from any host and it's intended to go to any host. So this gives us the ability to ping between the computers. Okay, oops, there's a typo here, has to be separated with a dash. Good. Now that's how you set up the ACLs. Next, we are going to apply those ACLs entries, those ACL entries we just created on the port, on this port right here, fast Ethernet 0/0, okay, which is inside. If the traffic is coming from the bottom down here up through router 1 trying to reach R2, this interface fast Ethernet 0/0 is going to be in, and then this port is going to be out. Okay, so interface fast 0/0, we're going to say IP access group 100, the 100 we just created earlier with the access control list, and then we're going to say in, okay, because it's coming in to router 1 from this subnet of 4 computers. That's where we're applying all these permit and deny entries. Okay, and then end. Now let's verify whether what we have configured is not working. Okay, let's go on PC1. Remember earlier all these computers were able to ping and telnet to R2, but this time what we have configured with the ACL is to only permit 1 and 2 to ping and telnet to R2, but deny telnet from 3 and 4. But however, go ahead and let ping from 3 and 4 also to go through. Only telnet be denied. Okay, let's verify that. Exit. Okay, let's try to ping R2 from PC1. See, the ping is going through. About about telnet? It should work. See, it's working. Password Cisco. Enable. Okay, Cisco admin. See, we're inside the router. Okay, perfect. From PC1. Same thing with PC2. We should be able to ping and telnet to R2. This is from the earlier session. Let me go ahead and exit. So ping the router 2. That's good. How about telnetting to R2? It's also working. Username, password, enable, and the password is Cisco admin. See, we have the running configurations. We're now on the router R2 from PC2 to R2 using ping and telnet. Next, we're going to verify that computer 3 and computer 4 still have the ability to ping and telnet to R2. They should not have the ability to telnet now with the new ACL we configured on R1. Let's verify that. Ping the router. See, the ping is going through, but we should not be able to telnet because the new ACL we configured on R1 is blocking the telnet traffic. Okay, that's good. How about computer 4? Can we ping R2? Yes, the ping is going through, but the telnet session is going to be blocked because that's what we have configured on R1 interface fast Ethernet 0/0. So that's good. How about PC5? Are we still able to ping R2? Neither. Still, that first ACL we configured on fast Ethernet 0/1 is still functional. Okay, it won't let it telnet either to R2. Okay, this is the first ACL we configured, the standard numbered ACL. Okay, next, let's verify that we still have connectivity between the PCs, which was one of the requirements for the new ACL we configured. Okay, the extended numbered ACL. Let's try to ping computer 1 from PC5. Okay, we should be able to, because that's what we were asked. So the PC5 is able to communicate with these computers down here, but it's being blocked from reaching R2. So that's good. Try to ping PC2 using PC5. See, it's working. And then PC5 trying to reach computer 3. It's also gonna work. So that's good. And lastly, PC5 trying to reach computer number 4 is also working perfect. How about PC1 trying to reach its fellow PCs and computers within its subnet? Okay, let's see. Can PC1 ping computer 2? Let's see. It should. Great. See, the ping is going through. And 3 is also capable of pinging PC1 as an example. So the ping is going through from PC3 to PC1 to PC5, but PC3 and 4 cannot telnet to R2. They cannot telnet to R2 because the new ACL we configured, the second ACL we configured, is blocking the telnet session of computer 3 and computer 4. It's being blocked from being able to reach R2. Guys, that's how you configure standard and extended numbered ACLs on a switch or a router. In the next video, I'm going to discuss how to configure standard and extended named ACLs. Thanks for watching. I'll see you in the next video.